Hello, I'm Savindra Pereira. In this video, I'm going to talk about linked list. Let's see what is actually a linked list. A linked list is a linear collection or a sequence of self-referential class objects called nodes, connected by reference links, hence the term linked list. Typically, a program accesses a linked list via a reference to its first node. The program accesses each subsequent node via the link reference stored in the previous node. By convention, the link reference in the last node of the list is set to null. Data is stored in the linked list dynamically. The program creates each node as necessary. In here you can see a graphical representation of a linked list. It has H in the first node and Q in the last node. You can see the reference link in the H node is connected to D node. An important thing you will notice in the last node Q is the reference link is set to null, which implies it is the bottom node in the list. Let's discuss some of the advantages of using linked list. Linked lists provide several advantages. A linked list is appropriate when the number of data elements to be represented in the data structure is unpredictable. Linked lists are dynamic, so the length of a list can increase or decrease as necessary, whereas size of an array cannot be altered. It's fixed when the program creates the array. Conventional arrays can become full. Linked lists become full only when the system has insufficient memory to satisfy dynamic storage allocation requests. Linked list can be maintained in sorted order simply by inserting each new element at the proper point in the list. Existing list elements do not need to be moved. Let's talk about some performance facts in linked list. An array can be declared to contain more elements than the number of items expected, but this wastes memory. In these situations, linked lists provide better memory utilization, allowing the program to adapt to storage needs at runtime. Insertion into a linked list is fast. Only 2 references have to be modified. All existing node objects remain at their current location in memory. Normally, the elements of an array are contiguous in memory. This allows immediate access to any array element because its address can be calculated directly as its offset from the beginning of the array. Linked lists do not afford such immediate access. An element can be accessed only by traversing the list from the front or from the back. Now let's discuss about how insert and remove methods in linked list are manipulated using diagrams. Method insert at front places a new node at the front of the list. You can see the linked list has 7 as the first node, and the new node containing 12 needs to be added at the front of the list. In order to do that, the first node reference link need to point at 12 and the reference link in 12 need to point at 7, which was the first node previously. Rest of the nodes in the list remain unchanged. Method insert at back places a new node at the back of the list. You can see that the linked list has 11 as the last node and the new node 5 needs to be added at the back. Therefore, the last node 11 needs to point at new node 5 and 5 become the bottom node in the list since it does not have a reference link pointing to another element. Method remove from front removes the first node of the list and return a reference to the removed data. In the image you can see the first node in the linked list is 12. So in order to remove the first node, which is 12, the first node now needs to point at second node, which is 7. Then 7 becomes the first node as the node 12 gets removed from the list. Method remove from back removes the last node of the list and returns a reference to the removed data. In here, the last node of the linked list is 5, which needs to be removed. Therefore, last node needs to be now point at 11, which is the one before the last data element. Data element 11 becomes the last node of the list as 5 gets removed from the data list.